All right, our notes for today are going to be pages 15 and 16. Inverse functions is the title for that page. On page 15, I would like you to put in the two definitions we had, the definition for one-to-one and the definition for inverse function. We had our definition for one-to-one on another sheet of paper, so if you did not have that, get it copied over onto this set of notes. And then we're going to start on page 16. Our title is Inverse Functions. And on the sheet of paper that you picked up today in class, make sure that you cut out the three flaps. So we have three different flaps that are going to open. We'll have three different ways to find an inverse. The first way is finding an inverse from a table or a set of ordered pairs. And to find the inverse using a table, we're going to switch every x value and y value. For example, in this table, we have x is 1 and y is 5. So our inverse, we will switch those points and have 5, 1. Or x is 2, y is 6. We'll switch those, so x is now 6 and y is 2. Or for 3, 7, we would switch them and it would be 7, 3. And our last point from 4, 8 would become 8, 4. And that would be our inverse table. Or if you have a list of ordered pairs, we would do exactly the same thing. The ordered pair 0, 2, in the inverse we're going to switch it so it becomes 2, 0. Or the point 4, 9 will be switched and become 9, 4. We can also find the inverse of a function from a graph. And to do that, we're again going to switch every x value and y value from every point. And there's a side note here that I want you to make sure that you understand. It's that the graph of the inverse is always a reflection of the original graph across the line y equals x. So for example, we have this function that is a line. Okay, so this is actually, we could write the equation for this, but we're not going to because we don't care what the function equation is because we already have the graph. But we do care about what the points are. So for example, this point is negative 1, 1. And then our next point is negative 2, 3. And then our next point is negative 4, 5. And we can continue. This point is 0, negative 1. And this point is 1, 2, 3, negative 3. And this point is 2, negative 5. So when we come over onto our inverse graph, we're going to switch the x and y values for every point. So this point would become 5, negative 4. And this point would become 3, negative 2. And this point becomes 1, negative 1. And this point becomes negative 1, 0. And negative 3, 1. And our last point is negative 5, 2. And we could, once that's done, ooh, something went wrong there. What happened? 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 2, 3. Will become 3, negative 2. 1, 2, 3, negative 2. Negative 1, 1 becomes 1, negative 1. This point should have been negative 3, 5. There was an error there. So we're going to cross that one out and fix it so it becomes 5, negative 3. Notice that I knew there had to be a mistake because this original graph was a line, so our inverse graph also has to be a line. So that's how we knew that that one point was out of order. So I should be able to come in and draw in the graph of my inverse function. Notice that if I had folded this graph over this line y equals x, I would have ended up with this inverse graph function. All right. And our last way to find inverses is from an equation, and we've done this in class already. So in your equation, replace x with y and y with x, and then typically we solve this new equation for y. So for example, if we have the function y equals 3x minus 4, our first step is to switch our x and our y. So we're going to have 3x equals 3y minus 4. And now we're going to solve this equation for y. To do that, we have to add 4 to both sides. Be very careful here. X plus 4 is not 4x, but just x plus 4. I see that mistake often. That's a common mistake that students make. We're going to bring down our 3y, and now you need to divide both sides by 3. You can either make sure that your division line goes underneath all of x plus 4, or you can put x plus 4 in parentheses to make sure that you know you're dividing everything by that 3. And then often we will rewrite that so that the y is in front. So y equals x plus 4 divided by 3. Or for our second example, we have y equals x divided by 2 plus 5. So we're going to switch our x and our y. X equals y divided by 2 plus 5. And now we're going to solve this equation for y. So subtract 5 from both sides. Again, that's just x minus 5 equals y divided by 2. Again, anytime that you're going to be multiplying or dividing, I recommend that you put that in parentheses right away, because when we multiply this side by 2, we have to remember that it's multiplying that entire part of our function by 2. So this is y equals 2 times the quantity x minus 5. And you can either leave it like that or you can distribute that. So we would have y equals 2x minus 10. Either way is fine to leave that like that. Okay. Our very last note that I want you to add today is regarding inverses of a function. So if the inverse of a function is a function then we use the notation f negative 1 of x, or the inverse of x, to define the function. So sometimes, and I'm going to go ahead and highlight around that because it's kind of important, and we'll talk more about that as we continue on with this unit. Sometimes the inverse of a function is going to be a function and sometimes not. So for example, if we look at our example where we were finding the inverse from a graph, when we found the inverse of a function, it was still a line, so we never had points that repeated up and down. So this was still a function. We could give this name f inverse of x. Okay, and we can only do that if our inverse is actually a function, and there will be times when it doesn't always work out that the inverse is a function. That's it for your notes today.